This video contains the solutions to the take-home problems number 16 handout. For this first problem, we're asked to find the end behavior of the function f of x equals 2x to the fifth. So the first thing we need to think about is the end behavior of just x to the fifth. So ignore the 2 temporarily. And what we know is that since 5 is an odd number, the general shape of that graph looks like this. And what we see is that as x goes to infinity, in other words, as x becomes a larger and larger positive number, x to the fifth also goes to infinity because the function is going up. So the y values are getting larger and larger and larger, going off to infinity. And then over here on the other end, what we see is that the y values are going down, and that means that as x goes to minus infinity, as x becomes larger and larger negative numbers, x to the fifth is also going to minus infinity. And so now the question is, what does multiplying by 2 do to that basic behavior? And the answer is that it doesn't do anything to that. It just means that the y values go to where they're going twice as fast. It doesn't change whether they're going to positive infinity or negative infinity. So what we see is that as x goes to infinity, f of x goes to infinity, matching the behavior that we saw over here. And then as x goes to negative infinity, f of x goes to negative infinity. Again, matching the behavior that we saw over here on the graph of y equals x to the fifth. And that's how we're going to break that down. We're going to think about the basic power function, and then we're going to think about the effect that multiplying by the coefficient has. So this is going to be how we're going to write our answers to these kinds of questions. All right, similar question here, f of x equals negative 3x to the sixth. Again, think about the basic behavior of y equals x to the sixth. Since 6 is even, that graph is going to look something like this. So this is y equals x to the sixth. And then what we see is that for positive values of x, as x gets bigger and bigger, x to the sixth also gets bigger and bigger, positive. And then again over here, as x becomes a larger and larger negative number, as x goes to negative infinity, x to the sixth also goes to positive infinity, again because the y values are going up on both ends. And again, the question now is, what effect does multiplying by negative 3 have? Well, we're multiplying by a negative, and so that means that instead of my y values going to positive infinity, my y values are going to go to negative infinity. So what we see is that as x goes to infinity, my f of x goes to the opposite of what x to the sixth does, namely negative infinity. And again, as x goes to minus infinity, f of x is going to do the opposite of what x to the sixth does, which means it's going to also go to minus infinity. And there's our result. All right, one more like this, and behavior of 0.24 times x to the eighth. Again, start with just looking at x to the eighth. 8 is an even number, which means our even power function looks something like this, a basic U shape. And then again, this is the graph of y equals x to the eighth. And what we see is similarly to the one in the previous problem, x to the sixth. As x goes to infinity, x to the eighth goes to infinity. And as x goes to minus infinity, x to the eighth goes to positive infinity. And again, as usual, now the question is, what happens when we multiply by 0.24? Don't get thrown off by the fact that that's a decimal. So 0.24 is a positive number, which means my behavior is going to stay the same. Multiplying by a positive number doesn't change the end behavior. So that means that my end behavior of f of x is the same as the end behavior of x to the eighth, namely that f of x goes to infinity on both sides. All right, now we have end behavior of a polynomial. And the key observation here is that whatever the leading term of this polynomial is going to dominate the end behavior. So in other words, we can, for the purposes of end behavior, we can ignore everything except the leading term. All right, so what's the leading term of this polynomial? Well, the leading term is the term with the highest power of x, and in this case, that's the x to the seventh. So what we're really asking ourselves is, what's the end behavior of negative 2x to the seventh? All right, and we're going to break this down just like we did the previous problems. X to the seventh, well, 7 is an odd number, and so the graph of y equals x to the seventh is going to look like this. And so now the question is, what's the end behavior? Well, as x goes to infinity, x to the seventh goes to infinity, and as x goes to negative infinity, x to the seventh goes to negative infinity. And now the question is, what effect does the coefficient have? So the coefficient is negative 2. Since the coefficient is negative, it's going to change the sign of the end behavior. So it's going to do the opposite of what x to the 7th does. So as x goes to infinity, f of x, well, x to the 7th went to infinity, so f of x is going to go to minus infinity. And as x goes to minus infinity, f of x, well, x to the 7th went to minus infinity, so f of x is going to go to positive infinity. So it's all about the leading term. Once we figure out the end behavior of the leading term, that's the end behavior of the entire polynomial function. All right, one last one here. Again, we want the end behavior of this function, so we need to find the leading term. The leading term is the term with the highest power of x. That's x to the 3rd. And so the leading term is negative x to the 3rd. Remember that those minus signs go with the term that they're in front of. So that means that my leading term is really negative 1 x to the 3rd. So what's the end behavior of that? Well, 3 is odd, so the graph of x to the 3rd looks like this. And the end behavior is that as x goes to infinity, x to the 3rd goes to infinity because the function's pointing up over there. And then as x goes to minus infinity, x cubed goes to minus infinity because x cubed is pointing down over there. All right, but now we're multiplying by negative 1, so as before, that end behavior is going to flip. So as x goes to infinity, x cubed was going to infinity, so f of x is going to go to minus infinity. And as x goes to minus infinity, x cubed was going to minus infinity, so f of x goes to infinity. And there's our end behavior.